Good afternoon. Yes, we are talking now about innovations coming from suppliers. The first speaker today spoke about users' innovations, and we're trying now a little bit what the market is pushing on us and what solutions we can present to that. We all know what drivers are currently in the market. The cities grow, people get older, they stay in their houses longer. There's more legislation for handicapped persons, which results in new designs and different requirements for installation and servicing of lifts, which have to fit in new and existing buildings and still offer increased ride comfort and car efficiency. So what does that mean in the practice? We are looking for creating bigger car footprints by smaller drives and smaller traction media. We are looking at best space utilization in the building. Machine room less is one of the answers. Reducing weight to increase car capacity, and also reducing power consumption to be green and to be more efficient in cost. That has led to a new development that we are looking to increase traction efficiency in combination with new traction media to build smaller. And that trend has, over the last 10 years, that we moved from traction and diverting pulleys from about 400 mil to 240 and then to 120. And that means basically that as on the right-hand side you see what that effect is to get smaller. That smaller pulleys have smaller bearings, and also traction media, which is reduced to 6 millimeter, has less tensile strength compared to a 10 or millimeter rope. That means we need to have an increased amount of ropes and also an increased amount of pulleys to ensure the same bearing lifetime. Then we get some problems in that new small system. The first one is related to friction. I indicated already that the new traction media, such as plastic-covered ropes, they function only because they have a high coefficient of friction on the outside of the rope. That's their purpose in life. Because we don't want to have V-groove traction media anymore. We want to have round grooves. We want to build smaller, so we don't have so much efficient contact area. Therefore, we need a higher coefficient of friction. But that brings the next problem to us, is that during the installation of these multiple rope sets, so in an old elevator compared to 8 millimeters, we had maybe 4 ropes. We are looking now to 6 to 8 ropes to handle the same loads. The installation is quite difficult because as soon as you have pulled the first rope through, all the pulleys in the system are blocked because of the high coefficient of friction. So the second, the third and the fourth are difficult to pull in. So that means a lot of time-consuming action. Also, the tensioning of the whole system is more difficult because basically every contact point of the traction media, being it the diverter pulley, the car pulley, the counterweight pulley, is a block, a brake, because you are looking at high friction. That leads to very long installation times and in many cases also a not properly executed tensioning procedure. Because again, you have not the option at the end termination to get the right tension back to the traction sheath. Also in operation it gives problems, these breaking points at every pulley. It is possible by this multiple rope system and multiple pulley system that between the different pulleys in the suspension section there is different rope tension. So that even one rope in a suspension system has a different tension before the pulley than after the pulley because of the friction and also the powers brought in the same pulley by the other ropes. Typically, we have seen with this new traction media that the normal maximum rope tension deviation of 5% is over-exceeded by high numbers. If that happens also in steel ropes, which has a little bit less friction problem, but this high tension from one of the rope in the rope set can lead to an accelerated wear in the traction sheath. An accelerated wear in the traction sheath means also an accelerated deviation in the diameter of the traction sheath on that specific groove until it has gone down, and then the other partners will take their share. This all leads that the traction media lifetime is reduced dramatically. The plastic covered ropes were marketed with lifetime of 1 million cycles, and many of you have seen failures at 100,000, 200,000, 300,000, and that means a lot of extra cost for the owner and a lot of headaches for the supplier, because 300,000 is far within the warranty time. So there was a lot of discussions about it. A second problem is created by the deviation in rope diameter and the tolerances in the groove, especially in the traction, but also potentially in the diverter or the car pulleys. This table shows you an overview of different pulleys. I took a comparison of a 320 to 160 and a 240 to 120, using either a 6 millimeter or an 8 millimeter rope. And I hope this was the point. No, this was not the pointer. Okay. For the ropes, I took -1% to 5% more. And for the grooves, I took a groove which was 1 millimeter less up to 1/10 higher for the same pulley. And you can see that due to the smaller pulleys, which make more revolutions to run 10 meter, you can get a length difference per pulley section of about 84 millimeters between one rope set. Again, say you have 6 ropes, the one is nominal, the one is 1% less, the other one is 5% more. They run in different grooves. So in the extreme situation, you can get between 2 pulleys already this 80 millimeters difference, which again leads to difference in tension between the sections of the rope set, suspension. So this length difference can even increase when there's more pulleys in the system, which it is in small pulley systems of suspension systems. Groove diameter, typically differences in the traction sheath, so that part of the equation is mainly concentrated on one sheath, unless you have very bad car or diverter pulleys in your system. And also the reduced possibility to slip over those pulleys. The end termination cannot compensate for this length difference, because again you have these breaks in your system. Yeah. The result of that we already discussed. The expected rope of traction media lifetime is not reached. This can even be accelerated, this process or this failure, by bad design or installation quality. If you don't start with trying to get an equal tension in your system, then you already have a problem built in at the start. If you have shocks coming out of buffering or emergency stops, that will also not help to bring an equal tension in the system. Wrong alignments or higher deflection angles is also known as a killer for the ropes. What is the innovation I would like to present to you today? Is that we thought about how can we solve this? How can we neutralize this friction, and how can we compensate for this length difference? In a rope set, the length difference means different speed between the different ropes, because you want to be at the same end. So if you have a longer rope section, you have to run faster. So we created a pulley, which is basically a main body with the classic 2 bearings and independent grooves, which can rotate over the main body. So every groove can adapt to its own speed, plus minus to the total speed of the pulley. This results in longer lifetime of the traction media with higher ride comfort. You take out all the shocks, etc. So you allow the rope to slide, even if it's fixed in the groove. you just slide the groove with the rope. This is again a picture of the whole system. Where was the? But okay, you see the body and you see the yellow separate rings on top of it, which can then move independently. In this picture, you see a start with the arrow. After so many rollovers, you see that the arrow is moving. Now I should see a short animation. Look at the arrow, please. Then, or this is the effect of presentation. Yo, there it goes. Thank you, Sam. You see, in this case, the first rope had a higher speed than the other ropes set and was moving faster over the pulley than the average of the whole rope set. This was a live sample in a station in Nuremberg, where Smith & Zoon had also a system installed with fixed pulleys. They changed that system with our EasyFlex, and you see after a while that these markings have changed positions. So that means there was actually a change and length difference to be compensated. In the laboratory test, we saw before and after installing. It's a little bit arbitrary because, again, if you change pulleys, then it's always a little bit difficult to come to the same system. But before, they definitely saw a difference between the tension in the ropes, and using the flexible pulley, they saw more equalization in the same system, only changing the pulley. So, the conclusion. Using smaller traction media has an advantage, but also gives you a problem in friction and speed differences. If you using these flexible pulleys, you can compensate for that, reaching a faster installation, because again, if you have the independent grooves, it's easy to pull the next rope without the blockage which I discussed before. You have a better ride comfort, and also the tension is reaching the end termination. And with this patented system, you can reach all these benefits which I try to explain to you. So, fast, quick and dirty, but it works. Thank you.